And then reactivity of allylic carbons. So first off, vanillic, that's the vanillic
Right.
hydrogen. Allylic's the really the one of interest. And being in an allylic position makes it more reactive. In the book it talks about how in SN1 mechanism, if your halide is an allylic halide versus a non-allylic halide, it's going to be more reactive. Likewise, even in SN2, when you have an allylic bromide, it's more reactive than a non-allylic bromide.
Because it can stabilize it through resonance.
This one, you can think of stabilizing because there will be a positive charge.
Mhm.
This one is still SN2, so there's not going to be a positive charge, but the book talks about the fact that here, because it's a double bond, you have less hydrogens than you do here,
Mm-hmm.
and how this rotates, there's not going to be as much interference as there is in this one. And then it also talks about just the fact that it said the LUMO of this guy, because it's in this pi system, the LUMO of this guy can be removed through the whole molecule. So then when the nucleophile comes and attacks, it has the LUMOs at a lower energy. I have a hard time picturing that in my mind, but the book says it, so just something to maybe remember.
Okay. So for the, so that's an alkyl halide. So what's the mechanism for the sodium cyanide on the bottom one for the double bond? Like, what's
Here?
going to happen? Yeah.
It's still just going to attack here, bromine falls off. It's just an SN2.
Okay.
It's just knowing that having that here makes it more reactive.
Okay.
That's really the big idea.
So just having a double bond will make it more reactive to.
Yeah. And then, I put this up, I was going to write some more, but remember the chart from chapter 8, how we have alkyl halides, and then you have your nucleophiles coming in, so your SN2.
Mm-hmm.
Like, your secondary is going to be SN2, your tertiary is E2, SN1 if it's cold, that deal. But if these are allylic alkyl halides,
Mm-hmm.
then SN1 competes more. Now, whether or not SN1 is predominant over SN2 or E2, I don't really know. Doesn't really say. It just says that SN1 is now more likely than it is if it's not allylic.
Okay.
So like if this was, if I made these, so primary is going to be SN2, but if I made these secondary carbons, this one will have a greater chance of going SN1 than this one would. This one's going to have a much higher percentage of SN2. This one, SN1 percentage is raised. Whether or not it's more than SN2 probably depends on a lot of factors, but
Mm-hmm.
it's kind of a trend you need to know. A lot of these things from 8 and 10, it's like, here's trends. Nothing in chemistry is like, it always happens this way,
Right.
usually. And then also knowing that this hydrogen here in the allylic position is more acidic, so you have a more chance of deprotonating this.
Okay.
Also, you have a greater chance of forming a free radical there on the allylic carbon.
Mm-hmm.
So your free radical reactions are also more reactive at that position.
For so for the addition of water, so what is that? Just salt osmosis on the top one for the more
Yeah.
reactive. So is it just gonna end up with a but it's tertiary, so they're just gonna do SN1 and
Yeah.
then create an alcohol.
Mm-hmm. Yep. So you should probably get is your major product. You'll have this, and then you'll have the same deal here, but
Yeah.
without the double bond.
And if you reacted it with the sodium cyanide instead, would you end up with like a trans double bond, a trans conjugated double bond?
Oh, so if you reacted this with it,
Yeah.
there's a chance it could go SN1, and you probably still have some E2 occurring there. So yeah, probably another.
Okay. I just wasn't sure because for the alkyl halide, alkyl halide. so not knocking.
Yeah.
Really.
So here I was showing that, here's the trends we learned in chapter 8 for this, for the secondary.
Okay.
But if this was an allylic alkyl halide, then it's more likely that these would be SN1. Not more likely to be SN1 over SN2, but SN1 is now more likely than it is when it's not allylic.
Right.
Same here in tertiary.